So let's go from division to multiplication by turning this fraction upside down. And let's set up our new fractions. Now look at these 4 pockets individually and think about what you can do to clean them up. For instance, bottom left here, I can actually take out a GCF of 4x. And if I do that, I'd be left with x plus 3 inside. And you know this is legit because if you go 4x times x, it's that. And then 4x times 3, it's that. If I distribute in my head, that's what I get back. That's how I know that this is legit. Now up here, this is one of those themes where you go back a couple of years in math class. Remember how they taught you to do this? Maybe you did like a magic X or a snowflake or a box method. I don't know how they taught you, but employ the method that they showed you and that this here turns into x minus 4 times x plus 3. Because if you distribute this, you get back that there. Now, these ones here, they look the same, but they're backwards. I like this guy because the variable comes first. Let me keep that the same. This one here, that 6 minus x, let's do some scratch work. 6 minus x is the same as negative x plus 6. I will put the invisible one right there. And now let me factor out a negative 1. If I remove negative 1 by dividing it away from that and that, I'm left with x minus 6. So these are all equal. This equals that. So if you don't like that, you can replace it with this because they're the same thing. And I'm going to do that back here in the main problem. Instead of 6 minus x, I'm going to write that. And the reason I did this is, first of all, I have permission to do that because these are equal. But the reason this is good is because now the x minus 6 knocks out the x minus 6. So these are gone, which is why we did what we did over here to turn this into that. Also, x plus 3 knocks out x plus 3. So these are the pieces that have survived. And really nothing goes away. Like that 4 does not knock out the 4. That doesn't happen. I guess you can knock out the 1s, but if you knock them out, they would pop up again because it's just a 1. So really, this is all that we have left. So this is the final answer. You don't have to distribute the negative 1, but if you want to, you can. It doesn't really matter. That's the one.